Okay, so we were talking about section 5.5, the substitution rule, and I want to do a problem that's a little more challenging. So let me give you a moment to copy this example down. Okay, so this particular problem let's see, I want to make, so John's having a little trouble seeing it. Is everybody else seeing the example okay? Give me a thumbs up if you're okay. All right, very good. Very good. So John, maybe log out and come back in. That might be, I don't know what's going on there, but sometimes that helps. Sometimes that helps. Okay, thank you, everybody. Now, one thing that we can notice here with this problem is that 49, if this thing will this work or not? 49x squared can be written as 7x quantity squared, right? 7x quantity squared. We need to do a substitution here. What substitution do you think we might try?
7x.
7x. I agree, Saeed. I agree, Susanna. 7x is definitely a good choice. So we're going to let u equal 7x, and let's see what happens here. Okay, so I'll go to the next page. All right, so u is equal to 7x.
Professor, wouldn't it be u would equal inverse of sine 7x?
Well, you make a good point. You make a good point. You could let u equal Victoria, Shalom, that you could let u equal the arc sine of 7x. But the thing, and that's okay, that would work. I can tell you that would work. But I wanted to show you a problem where, you see, the thing is, this substitution here is a little complicated, a little more complicated than you're used to doing. And you might not think about doing that substitution. You might not. And it's okay to do two substitutions. And so the way I'm going to do this problem is I'm going to do two substitutions. I'm going to let u equal 7x, and then it'll turn out that dx will be 1/7 du. So this this integral with respect to x, okay, this definite integral, is going to become now this transformed integral with respect to u. The arc sine of 7x became the arc sine of u. dx is 1/7 du, and the square root of 1 minus 49x squared becomes the square root of 1 minus u squared. Now, also, the limits, that x equals 0 and x equals a 14, those change because u is 7x. So the u limit for the bottom, well, it'll stay 0 because 7 times 0 is 0. The u limit for the top would become a half because 7 times 14 is a half. So this here is our new integral. And I like that better because when I think about the arc sign, you know, I know that the arc sign is connected to 1 over the square root of 1 minus u squared, right? I know that. And so it's just like, well, at this stage here, when we get, one moment, when we get like, well, all right, let me make sure you're comfortable there. Was there a question?
Yeah, I have a question, but you can finish explaining. I'll ask after.
Oh, okay. Well, first, is everybody okay up to the bottom here?
I'm
Of
trying.
course, we're not. Yeah.
I don't get where. Wait, somebody had a question before me. You can ask yours, and I'll ask mine after you.
Yeah, I
Okay.
was just gonna ask, why didn't you multiply by 1 over 7, instead of like when you did 7 times 1 over 14 to get 1/2?
Oh, because the reason is we are going from an integral with respect to x to an integral with respect to u. And so these x limits here, the 0 and the 14th, those x limits we have to turn into u limits. Well, u is 7 times x. So 7 times 0 is 0. That's the u limit for x equals 0. And then 7 times the 14th is 1/2. That's the u limit for x equals 1/14.
Okay.
Okay.
I understand that. I was thinking about the first equation to start off. It was the square root of 1 minus 49x squared. Why did you change the 49 to 7x squared?
Well, I wrote 49x squared as, I recognize that as 7x times 7x.
Yeah.
And the reason I like that is because I have a 7x up here.
Okay. Yeah.
And you can see that because of that, I'm able to nicely convert that integral with the substitution of u equals 7x.
Yeah.
If I had like a, I'm sorry?
I've seen that you did that, but you did that just to make sure it was able to translate into the u for the u substitution.
Well, yeah, I wanted you to see so the 1 minus 49x squared becomes 1 minus u squared.
Mm-hmm.
And why is that? Because the 49x squared is the same as,
The 7x on top.
right, it's 7x quantity squared and u is 7x. So it's just really to help you. I mean, I didn't have to put that there, but I just thought maybe it was helpful.
Okay.
All right.
Yeah.
Very good.
Professor?
You're welcome. Yes. All right, Lillian's good. Clea, yes?
So I just have a question so I get why u is 7x, but like the 7x is from the sign or is the one inside the square root?
It's really what is critical is this here. But you need them both to work out. If I had in the denominator like the square root of 1 minus like 81x squared, then this problem wouldn't work out nicely.
Oh, okay.
It would not work out as nicely. So, you know, these problems are designed to work out, you know, if you do the right substitution. And
Yeah.
all right, well, very good, very good. So, like, for instance, if like, say you're doing this problem in your homework, and in the numerator you have the arc sine of 9x, well, then in the bottom you would have the square root of 1 minus what, if you had a 9x in the top there. Then in the denominator you'd have to have the square root of 1 minus 81x squared, because 81x squared is 9x quantity squared. Let me see here, hold on. Good questions. Let me see, there was a question. I don't know why it doesn't show me the, I'm trying to get this chat thing to show, but it's not. Just give me a moment here. What that thing is. So I see I got a person chatted something, but yeah. Well, I'll tell you what. Now we're not done yet. We're not done with the problem. We just made the integral look a little nicer. So now at this point, now we have to do a second substitution. We have to do a second substitution. And I'll not use u again, I'll use w. What do you think a substitution, yeah, what substitution would work here? What would be the right substitution?
Arc sine of u.
The arc sine of u. All right, so I'll just mention, John, I'm not sure what's going on. I'm not sure what's going on, John. This is going to be recorded, but I would say take your the Google settings, change the browser, adjust your Google settings. Like what I mean is remove your cookies in the Google settings. That sometimes helps. So just keep trying. Just keep trying, John. Okay. All right. Maybe change the browser. Google, how many of you are using Google Chrome for your browser to get in here? All right, quite a few of you, quite a few of you. You know, use something known. Don't use a funny browser, right? Use something known like Google Chrome or Firefox, something like that. All right, well, all right. So, yeah. Syed says maybe download the Firefox. Try that. Go ahead and try that. And this is all being recorded. All right, W is the arc sine of U. All right, so that's going to work. And I can see it's going to work very nicely based on this new integral. So we're doing a second substitution. W equals the arc sine of U. Now, as always, what I decided to do was I decided to write the integrand. The integrand is the arc sine of u divided by the square root of 1 minus u squared. But I'm going to write that as 1 over the square root of 1 minus u squared times the arc sine of u. It just helps me a little bit in terms of the substitution, because if w is the arc sine of u, then dw du is the 1 over the square root of 1 minus u squared. Okay, that's a derivative that you learned in calculus 1, the derivative of the arc sine. How many remember doing the derivative of the arc sine in calculus 1? Okay, good, good. I mean, it's supposed to be covered. Well, very good, excellent. So then dw is going to be equal to 1 over the square root of 1 minus u squared du. And so now hold on here. Now this integral with respect to u converts to this integral with respect to w. So instead of using one complex substitution, I use two easy substitutions. And that's an option, you know. That's an option. So of course the limits are 0.5. Those are your u limits. And since w is the arcsine of u, the w limits would correspond then to the arcsine of 1/2 for the top limit and the arcsine of 0 in the bottom limit.
But quick question, you don't have to do the W way, right? We could have done from the beginning the inverse sine of 7x. As
You could.
Okay.
You indeed could. It would be a little harder. You could, Lillian. It would be a little harder to compute your new limits, but yes, absolutely, absolutely. You know, the arcsine of 1/2. If you you know, draw a 30, 60 degree, 30, 60, 90 degree triangle, then those are commonly the legs of root 3 and 1, and then the hypotenuse of 2. That's a right triangle that you should have be familiar with from your trig days. Yeah. Well, yeah. So I'll mention here, John, just keep trying, keep trying. We can meet after class. I think you're going to need more flexibility than just Safari. I think you ought to be able to use different browsers, you know, I think, for computers, right? It shouldn't limit you to one. At least I've never experienced that. But all right, well, all right, just keep trying, keep, you know. Oh, I see. Well, when you go on Chrome, it tells you to use Safari. I don't know, try Firefox, and that would be, yeah, change your default browser. That's the best advice I think I can give you, and I think the students agree. And we will get that, you know, you're going to be able to get it resolved, John. Well, you know, so, all right, well, so why is the arcsine of 1/2 equal to pi over 6? Well, the sine of 30 degrees is 1/2, right, based on this right triangle here. And remember, the appendix in the ebook or your textbook, Appendix C, has a review of trigonometry. The sine of 30 degrees is 1/2, so the arcsine of 1/2 would be 30 degrees. But of course, we put in pi over 6. And the arcsine of 0 is 0. So now we're down to this very simple little integral. And we're almost ready to finish up the problem, but please let me know if you have any questions. Okay. Okay, well then let's go then to the next page and get our answer, our final answer. So the antiderivative.
Dr.
Oh, I'm
Judy.
sorry.
Oh, sorry. I had a question, but my computer freaked out for a second.
Sure, I'll wait. I'll wait.
So, like, once you simplify it as far as you can, in this case, I guess it'd be w, the derivative of w. Then you need to plug in your limits to, like, the previous substitution.
No. We're going to. Okay, that's a good question. So if I had an indefinite integral, so of course the antiderivative of w is w squared over 2. And I would get that antiderivative, and then I would plug back in what w is, the arc sine of u, and then I would plug the u in. But I'm not dealing with an indefinite integral. I'm dealing with a definite integral. So I can just keep moving forward with these new limits of 0 and pi over 6. I can use those. I can work with those. In other words, so now the integral, I just put in pi over 6 and 0.
Okay. And you got pi to the 6 because you had to change one. You had to
Well,
change
the
one
arc
half.
sine of a half.
The arc sine
So
half.
when
Okay.
you take the sine of an angle, you get a number. The arc sine of a number is an angle.
Okay, I
Now
see.
we work with angles in radians. So the sine of pi over 6 is a half. So the arc sine of a half is pi over 6.
Okay, cool.
Yeah,
I see
it's
now.
pretty good. Pretty good.
Thank
Okay,
you.
you're welcome. All right. Well, then let's see here. So of course, WebAssign is going to want answer in simplified radical form. It wants the exact answer. And when you work this out, your answer is going to be pi squared over 504. Quite a beautiful answer, really. Let me give you a moment to copy this down, and let's see if there are any questions. All right. Are there any questions at all on this example? Sure.
I think
Another
you
time?
sorry, another question. I think you mentioned it, but just to make sure, we don't have to go back and do anything with the U substitution. We just keep moving forward and use the W
That is
substitution.
correct. That is correct. And I will tell you, I have seen sometimes even instructors maybe go back to like plugging in the old substitutions and old limits, but why do that? You know, stick with your new limits. Okay, you're welcome. You're welcome. Yeah, this is fine. This is perfectly fine. That's right, Susanna.
Okay, cool. Thank you.
All right, you're welcome. All right, are there any other good questions? All right, let me stop the recording. Oh, sorry, Xavier, you asked one. What was your question, Xavier? Oh, how do we get w squared over 2? Okay. Well, the antiderivative of w is w squared over 2. Think about the opposite of the power rule. So I have a w. To get the antiderivative, w is w to the first. I'm going to add 1. And then below, I'm going to have 1 plus 1. That gets you w squared over 2. All right, no problem. Well, Franklin, the 49, you had You didn't have for the going back here, 49x squared is just 7x quantity squared. And you need that in order to get this substitution to work out nicely. That's the only reason I put it there. If you had like, say you had a 9x here, then here I would need an 81x squared for the problem to work out, because that is 9x times 9x.
We had a problem like that in our weather sign.
Have you had one like that already in the
Yeah, in
first
the weather
lab?
sign.
Okay, okay. For some reason I thought that was later on, but okay, okay. Well, I'm glad I'm very good, Leanne. Well, at least now you have a comfortable feel for it. And all right, well, very good, very good. Well, let me stop the recording here for a moment.